Hello guys, my name is Anurag Edlavatkar and we are going to see what is Python NumPy. In this particular video, we are going to understand few basic commands of NumPy and to understand this thing. This particular document I have picked from the original documentation of numpy.org, and this is the location where you can find this particular thing, that is NumPy, the absolute basic for beginners. Okay, so this is where you can see this thing. So NumPy is numeric Python, is a open source Python library. As you all know, is Python is a open source product, so development tool, so you can download it free and you can use it for commercial development. So in the same way, Python NumPy library is also an open source library which is used for this particular thing. So it is widely used for science Science and engineering, and NumPy library contains multi-dimensional array data structure. So we are going to see that particular thing and try to understand this thing. Okay, n-dimensional array and much more things are right there. So very first thing is how to install it. So for installation purpose, very first thing which we need is pip install NumPy. Now by default in Collab, which is a IDE, web-based IDE, which is useful product from Google. In this one, all the libraries are ready-madely installed. We don't need to install it, but for just information purpose, I am just going to show you how to do that. So you have to take exclamation mark pip space install space and numpy. Now in this case, it is already installed. Then second important thing is import and then my library name. So my library name is NumPy. Now this particular thing is sufficient. We don't need to do anything else. But suggestion is we should use alias name as np. Okay, this np can be anything. You can take ab or abcd or whatever you want, but best practice is to take it np right here. So you can import that particular library. Then what we have to do is we are going to create 1d is equal to, and right here I am going to create np dot array and parenthesis. Now np dot array parenthesis is the syntax. Okay, for any function this is the standard syntax. We have to put parenthesis right there. Then you have to put values. So for putting the values in list, you have to take for list you have to take square brackets. So 1 comma 2 comma 3 comma 5, and then you will display your array. Okay, so that is 1d array. So it will look like this. Then right here you will take a two-dimensional one. So a underscore 2d. What you are going to do is you have to take np dot array, then square bracket. Now as this is a two-dimensional array, you need two square brackets for that. So first one is 1 comma 2 comma 3. Then second row will be 2 comma 3 comma 4, and third row will be 3 comma 4 comma 5. Okay, and then we will display the value. So that is my two-dimensional array. Okay, this is my two-dimensional array. Now in the same way I will take a three-dimensional array. Okay, 3D array. My numpy supports nd array. Okay, so you can keep creating array in the same way, and you will find that particular thing. So this is three-dimensional array. So this is my first value, and this is my second value. Inside that you have this number of rows. Three rows are there, and you have three columns right here. So we are passing with the help of three square brackets, and then we are maintaining two-dimensional array inside it. So this is a two-dimensional array and this is another two-dimensional array inside it. So collection of two-dimensional array generates a 3D array. So this is my three-dimensional array. Now why to use Python? Why to use Python NumPy? So Python NumPy is very powerful tool, powerful collection of values where you will find that it is very fast as compared to list, tuple, set or dictionary, which the data types we have learned earlier. So it is very fast in nature and it gives me very fast values as compared to other one. Okay, so that is my NumPy, and it is very, like, it depends on the characteristics of the data and the data type of operations that needs to be performed. Other containers may be more appropriate, but in the case of array it is very fast in nature. So these are the things which we have to understand in this one. So I have added few important text in this one. Now fundamentals of array. So array fundamentals, what are the things? So I told you we can create with the help of np.array. What we are doing is we are initializing the array right here. Okay, we are initializing array. So my parenthesis and square bracket, and then I'm giving few values to it, and then I'm displaying the value. So this is my output. Now what I'm doing right here is I'm fetching the value of this one. So what will happen in that case? I will give a, suppose I will give index 0, so it will give me 1. If I will say index 2, if I say index 1, then it will give me 2. If I say index 2, it will give me 3. So this is index 0, this is index 1, this is index 2, index 3, index 4, and so on. So these are the values which we have. So now, like the original list, my like, that list data type, okay, list data type is mutable in nature. So in the same way, my array is also mutable in nature. So how it is? So suppose I will say index 0 is equal to 10, and then I display this one. So 1 will be replaced by 10. 1 will be replaced by 10. And in the same way, suppose I want to slice the value. So I say like a comma a colon square bracket colon 3. So it will give me first three values of that. That is index 0, index 1, and index 2. The rule is n minus 1. So due to rule of n minus 1, 3 will not be included in that. Okay, 3 will not be included in that particular thing. Now in the same way, suppose I want to say, suppose I will say like a is equal to, I'm creating one variable b, and I say like square bracket colon 3, or anything whatever is there. So let it be 3 colon, and now what I'm doing right here is I'm displaying the value b. So this is my output, and then what I am doing right here is I am replacing the value. So what I am doing, right, I will say b square bracket 0, and this one I will say like 40, and then I will display b. So 4 is replaced by 40. So you can do that particular thing as well. Okay, you can perform this particular operation. You can create high dimensional arrays also, like as I have already given you the example of 2D array. Suppose I say a and np dot array, and right here what I am doing is parenthesis square bracket and square bracket, because I want to create a two dimensional array. Okay, I want to create a two-dimensional array. 5, 6, 7, 8, and next one is 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so this is my two-dimensional array. Now, suppose you want to access any value from this, you can do that particular thing in two different ways. First one is, suppose you are saying like a square bracket, this is two-dimensional array, so this is my line number. Suppose I want to access 8. Okay, suppose I want to access let it be 11. I want to access 11. So this is index 0, row index 1, and this is row index 2. So I will give 2. Okay, and this particular value is column index 0, column index 1, column index 2. So this is 2. So it will give me 11. Okay, and in the same way, suppose I want to give like this one. Okay, I want to give like this one, like 2 comma 2. So again it will give me 11. Okay, it will give me 11 in that case. Okay, so in that particular way. Now we are going to see attributes of array. So my array is a that is two-dimensional array. So ndim is ndim. So ndim will give me 2 because it is a two-dimensional array. Suppose I want to see the shape. So shape is equal to, it will give me 3 comma 4. Why 3 comma 4? Because we have total 3 rows. We have total 3 rows and 4 columns. Okay, that's why it is 3 comma 4. Suppose I want to see the size. So size is equal to what? That is 3 into 4, that is 12. And the last one where I can see the data type. So that is D type. So what will happen? What will happen in int 64? Okay, int 64, because all the values are my integer in nature. Okay, all the values are integer in nature. Now we are going to create array in different way. So suppose I want to say like first one is np dot zeros. Okay, and I will give 10, so it will generate it will create one dimensional array of 10 zeros. Then in the same way I want to create 1, so it will be, suppose 10 values I want, so it will generate 10 ones. Then you have something called as range. Okay, suppose you want to let it be, suppose I want to give np dot empty. So what will happen in case of empty? Suppose I am giving 2, so I'm getting 2 values in this one, and it may vary. Okay, it may vary, it may be something else also. Okay, suppose I rerun it, so this time the value changes, again I rerun it, so values are, so empty is like that. Then you have you can create array with range functions also. So you can create array with range. Okay, so my function is np dot a range. Okay, and right here I have to give like first one is like, suppose 4 I am giving, so it will generate 4 values. And suppose I give one more, that is np dot a range, and suppose I give like 1 comma 10 comma 1. Okay, so it will generate 1 to 9. N minus 1 rule will be applied. Suppose I want difference of 2. Okay, I want difference of 2. So right here what will happen? It will give me difference of 2. Okay, so there will be difference of 2. So in that way I can use a range function. And the last one which we are going to learn today, that is np dot line space. Okay, now line space function gives you space in between, equal space between the numbers. Okay, line space gives you, so suppose I say 1 comma 10 comma num is equal to let it be 10. Okay, so it will generate 1 2 3 4 like that. Suppose I give num is equal to, suppose I give num is equal to 5. So it will create with the difference. So total 5 values are generated. Okay, total 5 values are generated and difference is of 3, difference is 2.25. Okay, 2.25 difference is there. So right here you will find difference of 2.25. So in that way you can do lot many things with the help of your NumPy, and in upcoming videos we are going to see much more about it. Thank you very much.